All right, so we stopped the video in case I messed something up, but I just did the first dilution, which in the protocol I called one big dilution. So we've done that one. One thing, so we use this for that one big dilution. To make sure we know that this has been used, I'm going to write on it that it's been used. Okay, so this is no longer sterile, all right? So if we had some autoclave tape, I could also put some tape on it. Maybe, I was thinking about explaining about autoclave tape, but I don't think I will. Let's get on with the protocol instead. Right, so we're going to do another kind of dilution now. Instead of one big one, we're going to do, what do they call it? 5 smaller dilutions. So take 5 sterile 1.5 milliliter Eppendorf tubes. These are here. They're called Eppendorf tubes or microfuge tubes. Eppendorf's really the brand. It's part of Hamburg, actually, Eppendorf. So yeah, we'll take 5 of these. So these are sterile. So remember, when we've opened a sterile container, we want to close it up again when we're finished. I'm going to pick out 5, and I'm kind of picking them carefully so that I'm not sticking my fingers right in. I'm sort of picking them from fingertips again to keep the other ones sterile. 1, 2, 3, 4, 5. Close that. It's safe and sterile. And again, a good lab practice is if you're working in a shared lab, you usually each have your own boxes of sterile stuff, right? You keep your own box. So if you mess it up, you don't mess up other people's experiments. If you have contaminated something, as I've already shown you, you can eject the tip, put it into here, throw the tube in the appropriate place, or mark that it's no longer sterile. So it's a big problem if you think something's sterile and it's not, and it can completely ruin your experiments. Right, so it says take the Eppendorfs. Right. We're going to pipette. Right, we're going to do 5 1 in 10 dilutions. We're going to pipette 900 microliters of sterile water into each of these tubes. So we get to use another size pipetter, 900 microliters. We need to use a P1000, so that goes up to 1000 microliters. It would be a miracle if it's already set to 900. It's not. So, right, let's just show you the setting again. So it says 100 there, so that's the maximum. That's actually 1000 microliters because it doesn't go to single microliter resolution. It just goes to 10 microliter resolution. So let's put that down to 90, which will be 900 microliters, right? And this, the tips, the yellow tips we used before, won't fit this one. This accepts blue tips. So here's a box of blue tips.
And I think these pipetters are handy. If you look at the color on the top, it actually tells you which color tip box you need.
I never knew that. Pro tip. Thank you, Jasmine. Right. I never realised that. That's so cool. All right, so I've got my tip. I think I might have made the same mistake I made last time, not taking the lid, loosening the lid on the bottle. So we're not going to use this. This is already contaminated. We've already done our dilution. We're going to use a fresh, sterile bottle of water for these dilutions. And I'm being really careful not to touch the tip on anything. And I successfully didn't. Right, so take the lid off. Pipetted. So if you're pipetting into something sterile, you're collecting something sterile, we want to keep this sterile. We don't want to be moving things from the outside of it into the inside. So even if I touch the tip somewhere on the bottle, or on the rim of the bottle, I might want to change tip so I'm not bringing potential contaminants in. waving that around for a while. I'm going to change tip. Right, 900 microliters of water. So again, as I said, I kind of carefully went in. I was careful not to touch the barrel of the pipetta inside the bottle. And get my 900 microliters in there. And remember, just to blow out any drops that might be sitting behind. Again, this is something you just got to practice, but ejecting the water, the liquid, well, it's water in this case, kind of smoothly will help make sure you don't leave any behind in the tip. Now, we want to repeat this. This tip's still sterile. I haven't touched it against anything. I'm pretty confident I didn't mess anything up, so I can just reuse the same tip. So go down to that first stop, not the last one. Draw up 900 microliters, and careful not to touch the. So in that example, there was a tiny little drop left, and I touched this side of the tube, but I know this tube's sterile, so I'm still confident to reuse the same tip. And if I'm doing this kind of thing, and I wasn't trying to keep an entertaining commentary for you, I'd be counting 1, 2, 3, 4, 5, just helps stop you getting lost. Right, I finished. I've now put 900 microliters into each of those, put my lid on to keep it sterile, eject the used tip. Right, I'm going to prepare my plate. Should have done that one first, but it doesn't really matter too much. Another YAPD plate. I'm going to put my code number. I'm trying to keep these sterile by moving those there. It's a YAPD plate. And what did I say to label it? I said label it YAPD 5, because we're doing 5 dilutions 5 times. And then the actual dilution is 0.1. 10%, 1 in 10. So right, 900 microliters in each of those. Here's the same mixture I used before. What do I need to remember to do? I need to vortex it to resuspend the cells. Vortex. Okay, that'll be enough. Okay, in there. I might take the lid off there. A P200, still set at 100 microliters. So I'm going to draw out 100 microliters of the cell suspension. Close the lid again and pipette it into the first tube. Eject the tip. What was I going to say? Yeah, first of all, just to keep track of perhaps the numbers again. So the approximate density of cells in the mixture was about 10 to the 8 cells per mil. So I took out 100 microliters. That's 1/10 of a mil. So we'd expect now in here there's going to be 10 to the 7 cells in that tube, right? And actually, it's 10 to the 7 per mil because there was 900 microliters of sterile water in there, and I just put in 100 microliters of cells. Right? So we need to mix these. So you could put the lid on and you could vortex it, but actually it's as effective in this kind of situation to mix by pipetting. So remember, I changed the tip. That's quite important, because if there was anything left behind, I wouldn't be keeping. So you always get some cells left behind in a tip, and we want to do a kind of really clean dilution. I don't know how to use better words than that. I'm running out of words. All right, anyway, use the new tip. Okay, still 100 microliters. So this is the mixing step that I meant. So if you just pipette up and down a few times, that will make sure that the cells are well mixed. Okay. Now, I'm going to blow out any cells that were left in it. If there's a drop of liquid left behind there and I can't get rid of it, again, that's a good reason to change tip, so that we get exactly 100 microliters out of this mixture now. 100 microliters into the next tube, and I'm going to remember to eject the tip. Now, if you're doing long dilutions, it's quite easy to get lost where you are. So you can look at the level of the liquid in, because now this one has 1 mil, 1,000 microliters. This one has 900, and the rest still have 900. So we can see from the volume. But it's also another way to keep track. Might be you could just put the lid on the one that you've just used, so you know which one you're at. Sometimes if I'm doing lots, I might just move them up into a different row. There's obviously different ways you can do this. Anyway, those are some suggestions. Right, let's do the next dilution. Still 100 microliters.
When you do the pipetting up and down, can you pick up the tube? I don't know if they'll be able
that's a good
to
idea.
see it or not,
Yeah.
but
Right, so let's. Okay, so you can see, in this case you can do it fairly vigorously, but be careful you don't splash it up so that it touches the tip of the batter. Okay, now I want to make sure there's nothing left in that. And so again, there's a bit left behind, so don't really want that. So with a bit of practice, because I was doing a lot there, you can do it without needing to change tip. As I keep on saying, if you're in doubt, it doesn't hurt to change the tip. So I'll pick it up again, you can see I'm just going to draw out 100 microliters of that mixture. I'm going to put the lid on so I know where I've got to, and pipette that in. And I always have to change tip going down the dilution series. All right, let's finish the rest off. 100 microliters. Okay, that time I successfully didn't get any left behind in the tip, so I can just reuse the same tip. Good. And I've got to the end, the 5th 1 in 10 dilution, and we're going to plate that. Now, so beads, should probably beaded this first. I'm not actually reading the protocol, just talking. Should get some really kind of good rapport. You know, like test match special. Jasmine's Canadian, so she probably doesn't.
I have no idea what you're talking about.
She doesn't listen to cricket. I'm not really much of a sports fan anyway, but I do know that, cricket test matches when nothing happens for ages, the main job of the commentators is just to natter on.
I think they talk a lot about the food. That's what I've heard.
Anything, yeah. Yeah. I think that's the reason people listen to it more than cricket. Right, there we go. So, a few beads on there, something like 10-ish. Check my tip, and then do this spreading. And these are pretty wet plates. But you're going to be watching a lot of this, so you'll see how it goes. Right. So remember, before you incubate the plates, you don't have to. You can leave these a few minutes to absorb the liquid, but you do have to. When you're finished, before you incubate the plates, at the end of the day, well, after the spreading step, you just tap the beads onto the lid and tip them away to be re-autoclaved, to be cleaned. Well, these are kind of really solvent plates. I wanted to show you that. I'm going to do the next dilution step, but I'm going to repeat all this a few more times so we can have some nice dry plates. So yeah, before you tip the beads away, make sure that the surface of the plate is dry and that all the liquid from the beads has been absorbed onto the plate. Otherwise, you'll be chucking away some of your cells, and we don't want to be doing that. We're trying to get an accurate measurement. Let's close that off, and you can stop, and then we'll do the other one.